page 203, number 44.
Yeah.
And it's a diving problem. With what velocity will you hit the water if you step off from a 10-meter diving platform? Okay, so sometimes we draw a picture. This is 10 meters. And then we've got water. And then we've got our androgynous stick figure diver. Alright, and I guess we're going to assume that we don't have to worry about the diver jumping up.
That's on part B.
Oh, cool. Alright, so the diver in this case slips and just falls off the diving board and then goes into the water. What?
Is that
Reardon? Alright. So the only information we have is that. Okay, so what velocity will they hit the water? Well, what other piece of information do we know that's not in here? Yeah.
Acceleration.
Alright, so this is part A, by the way. Yeah, we know that acceleration is equal to what?
9.8 meters per second.
Meters per second squared. And we want to make sure our units are consistent. This is 10 meters, so that's 9.8 meters per second squared. So that's good. So how do we go from acceleration to velocity? We take the antiderivative. You guys remember that? So if A of t equals 9.8, take the antiderivative as we'll learn, it means the integral. We take the integral of both sides, and we say the antiderivative of acceleration is velocity. And when you take the antiderivative of a constant, it's going to be 9.8 t plus c. All right. Now what do we do? Well, it says, what will the velocity be when we hit the water? So for time, we have to figure out what? What do we have to figure out?
How long it takes.
We have to figure out when we hit the water. But right now, what's our initial velocity? It says if you step off from a 10-meter diving platform. So what's our initial velocity? 0. So at t equals 0, v at 0 equals 0. That means that c equals what? 0. Okay, so now we have v of t equals 9.8 t. All right, now this is my equation that I'm going to use after I find what? What do we need? Time. If we have time, we plug it into the velocity equation. Boom, we've got our velocity. So we need to figure out what time we hit the water. So I got to keep going in this process. What do I need to do to this equation? All right, I got to take the antiderivative of this. So that becomes the antiderivative of velocity is displacement. So we'll call that x of t. Maybe I should have called it y of t because it's along the y-axis. Oh well. Well, yeah, sure. Let's just do y of t. Y of t. And what's the antiderivative of 9.8 t?
9.8.
Yep, 4.9 t squared. Dylan, where did the 4.9 come from? Yeah, 9.8 divided by 2. If you take the derivative of 4.9 t squared, you get 9.8 t. And the derivative of c is 0, so that's why you don't see it. Okay, when t equals 0, alright, when t equals 0, y of 0 would be what? C, that's true, but what's before the diver steps off the platform, how high is the diver from the water? 10 meters, that's the information they gave us. So that means that C is equal to what? 10. So we've got the following, then we've got that y of t is equal to 4.9 t squared plus 10. So now we have the next question. Our whole goal was to figure out the velocity when the diver hits the water. So when the diver hits the water, what do we know about how high the diver will be?
Yeah.
0 meters from the water. So I could plug 0 in for what? Y. So we say 0 equals 4.9 t squared plus 10. Okay, so basically, what am I doing here? I'm saying y of t equals 0 when diver hits the water. Solve for this. You get negative 10 over 4.9 equals t squared. Okay, this is bad. Why is this bad?
Because your acceleration is positive, it should be negative.
Okay, very good. Well, okay, true. But it just depends. Acceleration can still be positive. Sure it can.
Well, it can be, but not in this case.
Yes, it can. It just meant we screwed up somewhere else. You're right. If I made acceleration negative, I wouldn't have had this problem. But I made it positive. And as soon as I make it positive, what does it tell me about perspective?
Tiny distance has to be negative.
And then my distance.
Has to be negative.
So once my acceleration is positive, what's our point of view?
From the water up.
From
From up. Down.
the other way around. From the board down. Right?
Yeah. So then it
So like from the point of view, if something's accelerating in a positive way, it's accelerating. What distance is increasing? The distance from the board is increasing. In that sense, we can say. So you're right. It would have been easier if we made acceleration negative because that's how we typically see things. All right, but for the sake of changing less of our work, we could say, oh well, originally we were talking about from the diving board, which means that when time is 0, my height isn't 10, it should be what? Negative 10, which makes C negative 10, which makes that negative 10, and that negative 10, and now that's plus. So we're okay. And we'll get the same time. All right? So maybe that's cheap, but it's really relative to your point of view. It's all based on what your perspective is. I mean, if you think of the picture, if I'm from the diving board, if my perspective is from the diving board, my distance from the diving board is increasing. Right? So this distance is increasing, hence the positive. But if we're from the water, the distance from the person to the water is decreasing, and that's why you typically use a negative acceleration. So as long as we stay consistent. So my problem was, I knew there was a problem when I had to take the square root of a negative number. So my problem was that my acceleration I had positive, but then I changed my perspective from the ground here, and I made the constant positive as well. And so I had differing points of view in the same problem. That's why we had the issue. Okay, over-explained that, but that's okay. So from this, we have t equals what? What's the square root of 10 over 4.9? Anybody got an answer to that? So I want to plug it into the calculator.
1.42.
Let's go three decimal places. 4 to what? 9 seconds. So we're going to take this and plug it into what? My velocity equation. Okay, so we say v at 1.429 is equal to, what was my 4.9? Oh wait, 9.8 times t, yeah. 9.8 times 1.429. Now, in practice, when you guys are on the AP test or you're doing problems, I would not plug in 1.429. Whatever this time was, just store it, right? Because there's probably a lot of decimal places. Store it in your calculator as t, maybe, some letter that would make sense to you. And then plug in 9.8 times whatever the letter you stored it as. You'll be more accurate. You don't have to worry about rounding mistakes. And so what answer do we get? 14 what? 14 meters per second? I think that's what my book says it should be. There we go. That's it. Let's